The SD Ruby podcast is brought to you by New Relic.
Good evening, everybody. So to talk okay, we'll do it again. Good evening, everybody. So tonight we will talk about Ruby 2.0. But before we start, I'd like to know who's using what Ruby. Do we have people using Ruby 1.8 still in the room? Yeah, we have a few people. Actually less than I thought. Ruby 1.9? Ruby 2.0? Hey. Ruby 3.0? JRuby? A few people. Ruby News? Mac Ruby or Ruby Motion? Yes, 1%. All right. Perfect. Okay, so today it's Ruby 2.0. So what's very important about Ruby 2.0 is that it was Barney Stinson approved. And that is a fact. I actually called him and we talked about it. What it really means is that we can all start using it. It's safe to use right away. Actually, the good people of 37 Signals already switched Basecamp to running on Ruby 2.0 in production, and they're fine with it. I talked to the guys from GitHub, and they were talking about switching. They did some tests. They had some concerns about performance and other issues they wanted to verify before switching. So it's really, really ready. I don't know if you remember the transition between 1.8 and 1.9, but it was kind of a hard transition for a lot of people, and it still is for some people. The transition between 1.9 and 2.0 is really different. The good thing is that there's no horse meat in Ruby 2.0, and Ruby is 20 years old. This was Matt's. I'm not sure if it was in '93, but that was Matt's, Yukihiro Matsumoto, the author of Ruby, who started Ruby in '93, released it publicly in '95, and we've been using it ever since. So we will first start focusing on what you really need to know, because there are a lot of blog posts out there, a lot of people talking about Ruby 2.0. So let's take a first step talking about what is very important. The most important thing is that the migration from 1.9 to 2.0 is really, really easy. And I really mean it. There's almost no reasons why you cannot upgrade an app from 1.9 to 2.0. The only reason might be that 2.0 is really new, you're on patch 0, and you might want to wait a little bit so other people find bugs. But your code, if you run on 1.9, it really should be able to run on 2.0 without any issues. The other thing is that Ruby 1.8 will reach its end of life in June. What that means is not that your app will stop working, but when it gets to June, there won't be any patches, no more security patches, no more fixes, nothing that will happen in 1.8 anymore. So you really want to think about transitioning all your apps to 1.9 by then. Otherwise, well, if there's a problem, you won't get any fixes. So even if you don't like 1.9, or even if you're not looking forward to the work you might need to do to switch to 1.9 or 2.0 directly, you need to realize you're going to have to do it eventually. The other thing is that there's actually real performance improvement with 2.0. Especially if you come from 1.8, you will really see a big improvement. And we'll talk about some of that in details later on. The other thing is Rails. Rails chose Ruby 2.0 as its favorite Ruby. If you start using Rails 4, which is in beta right now, you will see that the recommended Ruby is 2.0. And actually, if you use 1.8, Rails 4 doesn't run on 1.8. It just doesn't because of the syntax difference between 1.8 and 1.9. So really, we're looking at everybody migrating to 2.0 pretty soon. So what do we have in 2.0? We actually have way less new features than usual. Actually, almost not that many features, so I was able to list them and I will talk to you about them a bit further. Now what's interesting though is that because we have less features and because it's backward compatible, it's easy for us to switch. But really, Ruby 1.9 was Ruby 2.0. And Ruby 2.0 is just a point release. The switch from 1.8 to 1.9 is much harder than from 1.9 to 2.0. So we'll talk about some of the new features. Some are experimental and some are actually in place. Now because people are slowly migrating, you won't see all the new features being used all over the place, but I will show you some of the ones that I think are very interesting and people are going to start using soon. So if you remember REE, that was Ruby Enterprise Edition. And RE was very popular a few years back because it was allowing you to use less memory. And we'll talk about it. Basically, Ruby 2.0 does the same thing. So it really is a replacement for RE, especially when you use rescue and unicorn. A nice thing is that you already have full Heroku support. So you can actually deploy your app right now with Ruby 2.0 on Heroku and test it and see if that works, which is really cool. I used that. I actually tested with an app of mine. It works great. It was very simple. You just need to go into your Ruby gems and you see Ruby 2.0, and that's it. So that was a very trivial change, and that was working right away. So that's really good. Heroku also supports Matt and some other core team members. So they've been caring a lot about having people transition to the newest version. And finally, what's very interesting is that Ruby 2.1 has been scheduled for Christmas 2013. So for a very long time, the Ruby releases were kind of slow. We really did not know when they were coming. Now that's changing. There's a release schedule, and Ruby 2.1 is already scheduled for December. There's a list of features they want to have in. Matt already talked about it. People are focusing on that. So it's nice to see that there's a progression. Now Ruby 2.1 won't change a lot of things. It will be just a few improvements, but it's nice to see that Ruby is now having a proper release schedule. But you might wonder how to get started. And to get started is actually very trivial. Depending on what you use, your tool should be able to support the switch to 2.0. So with RVM, you just need to update RVM, and then you need to switch to 2.0. With RBench and chruby, I think you need to use Ruby build to get it updated. Basically, rebuilding or compiling Ruby 2.0 is as simple as Ruby 1.9, but you have two gotchas. And usually the tools you use will handle that, but in case they don't, you first need to have libyaml installed, and that's very trivial. If you use Homebrew, you just do brew install libyaml. And you also need to have a recent version of OpenSSL. And the reason why that's important is because on OS X, so on the Mac OS, you have actually an old version of OpenSSL. And Ruby 2.0 won't build against that. So you need to make sure you have an updated version. I think most of the tools out there now make sure you have the right dependencies, otherwise they fetch them and compile them for you. So if you use RVM, it's already built in. So what's in 2.0? Well, let's start by a very small, tiny feature that probably none of you really care about, is we have a default code encoding. So what that means is before, when you were writing your code, if you were using Unicode, or if you were using another type of encoding inside your code, you had to put the magic encoding that was saying this is the usually UTF-8 encoding. Now in 2.0 by default you have that built in. So you can use Unicode in your code and it won't break. Not a big deal for a lot of you, but if you use another language than English, and you might have comments that are in a different language, and you'd have to add all these comments and stuff like that. So now we have UTF-8 as a default code encoding. Now a more interesting feature is the keyword arguments. So that's interesting because depending on what language you come from, keyword arguments might mean different things. So I just want to explain to you in the context of Ruby. And then as we go drink beer, you guys can complain to me about why it's not the real keyword arguments or whatever you want. But this is the way it's implemented in 2.0. So before, when you wanted to have a method that would take a bunch of arguments, and you really see that in Rails a lot, you would define your method, and then you'd say options, and usually you get an option with a hash. Here I basically put two arguments. One is a name, that's a required param, that's called name, and the other one is the option. If you don't pass anything, you get an empty hash. And then if we want to set default values, we do that inside the body of the methods. Now with Ruby 2.0, what you can do is you can define a hash yourself in the definition. So you say create the first argument, and then you can say optional, the hash argument term of services, TOS, as a default value of false, and timestamp will be now, and then we get that automatically. Now what's cool is when you use it, it doesn't have to be in the same order. You can use it exactly the same way you add it with the first Ruby 1.8. So in Ruby 1.8 you have this option, so you could have timestamp first and term of services second in the hash. It didn't really matter. You see you have the same thing here, even though we ordered it in the definition of the method. So when I use it, I can say create mat, and then the default values are being set. Or I can just specify a specific one by saying mat, and I set the timestamp, or I could have chosen term of services or both. But there's one difference, which is if I set another value in the key in the hash, in this case location, that will raise an argument error. And that's actually a good thing, because we did not define in our API that we were accepting this key. So this is actually a good thing, because it will protect you from just shoving a bunch of data in your API without defining what you need. But Matt is a very nice guy, and Matt said, well, we know these Rails guys, they like to shove a bunch of stuff, they don't really know what it is at the beginning, so I'm going to let them do that by having this magical star star, whatever you want to call the argument. And what that means is, whatever is in the hash that's not defined will be available in this object as a hash. So now we get exactly the same behavior we had before, but we can actually put more stuff like location or sex or whatever you want in there. So this definition here is exactly the same thing as using just the hash, but it's defined. You have the optional values already defined. And it's easier when you look at the definition, you know exactly what's going on. Now, there's one problem though with this, and that's going to be fixed in 2.1. The issue is, while we have the first required argument, name is required. If you don't pass name, you can have an exception. There's no way for you to say, I'm requiring one of these params. So the only way to do that in the hash is to actually raise as a default value. It's kind of weird. It's like, okay, so I'm going to pass new mat, but I'm not passing the term of services, so the default value is raised, and that's going to raise to basically get out of the method and give me an error. And that's exactly what's going on here. And that's not really pretty. So in Ruby 2.1, they're going to fix that so you can have a required optional param. And the way it's going to work is that instead of putting a value, it would just be an empty value. So you say TOS colon and nothing. And that would mean this is a required field in my keyword arguments. So that's it for keyword arguments. I'll just stop here and ask if you guys have questions, because since there's a lot of content, it's better that I just stop and we talk about it. Yes?
Is there any reason, I guess once they get to 2.1 to not use the name parameters? Like, wouldn't you just send them all in as name parameters or keyword parameters? Like, why would you have name not be a keyword parameter?
So in this case, the reason why I didn't want it to have it as a keyword argument is because I don't want to have to specify it. I know that name is required, everything else is optional. In the case where name was actually required, I would probably just use everything as a keyword argument. You're right. This is more of a syntax. I wanted to show that you were not limited by just having the keyword arguments. You could have keyword arguments and other stuff at the same time, working in the same definition. In some programming languages, the keywords argument are basically overloading the same method, and based on the argument you pass, it will get dispatched differently. I wanted to show that it will be slightly different. But you're right, once we're going to have the required params, you could just use one big hash, or one big keyword argument. Other questions? All right, let's move on to a Prepen module. So this is an interesting problem we're having in Ruby. We don't really have decorators. We don't have a way to expand a method that already exists. So let's say you have this class that has this method. So we have a class called action, and you have this method called start, and you want to modify what start does. You have two options. One is to reopen it, and you just modify the entire body, you basically replace it. The other one is to use alias method chain. And alias method chain basically creates a new method and alias the previous one with the new one, so you can then call it. But it's kind of a dirty thing. It's hard to see what's going on. And Yehuda Katz has been hating on it for so long that people don't really know why, but they hate it too now. So the Ruby team came up with a nicer solution. And it's okay, we're going to have this, this module. And this module is what is going to modify what we want that's basically the code that's going to modify the original class. So we have a module, we have the same method called start, but here what we have is we call super. Now super usually calls the superclass, right? But in the module, in this module, there's no superclass. It doesn't call anything. So if I were trying to run this code, I would have problems. It would not work like that. So this is why we're gonna use Prepen. It was meant to be used with Prepen. So we reopen the class and we prepen Ruby it. So what that does is that it will change the call chain. It will first inject my method that we prepended, and inside that it will call super, which will call which will call this, and then after that it will add whatever I'm adding here. So that's the end result. So that's the end result. If I create an action.newStart, then now you would say just do it, and then better with Ruby, which was what I added here. So this is the concept of Prepen. It's a nice way of injecting code and doing decorator and working around a function that already exists. So because you have super, you can do something before or after without having to change the body of the original method. Any questions about module Prepen?
Can you return the value from super inside of your prepended method?
Absolutely, yes.
And then,
yeah, you could say foo equals super, that will call the previous one, and then do something with it. Absolutely, yes. That's basically what my code does here. I get the result from super, and then I add that, I create a new string with my own string. So that's exactly what I'm doing. I could say foo equals super, and then foo plus better with Ruby. That would have worked. You can also pass different arguments because it's super, so you could change the arguments that are called. So if start was taking an argument, I could modify the argument and send it to super differently. Any other questions? No? All right, lazy strings. Lazy strings are very interesting, especially if you do any type of functional programming languages like Clojure. People love lazy strings. They're also called lazy sequences. Or in the case of Ruby, they're actually enumerators most of the time. The idea is, let's have this problem where I want to know absolutely the next 13 Friday the 13th until the end of times. But I really don't know how long I need to look into the future to find these times. So, and if I create an array between now and the year 9999, that's going to be a huge array, right? If I create that array, it will consume all of my memory and the process will crash. Well, not if you use lazy. So lazy is a new argument that's added to an enumerator that basically, instead of creating the entire array, will go one by one through and will push down the chain. So we get the array, we take the first element and we push it down. So we go to select and then we check if the day is 13 and the day is Friday. If it is, keep on going. And we do that until we find the first 13. Once we have the first 13 dates, we stop. So we could basically do also from 0 to infinite, find all the prime numbers, or find the first 100 prime numbers. And we'll basically go through all of that without creating a huge array of all the numbers before starting. So in this case, the result will come back like that, and it will be really fast because it will just create the array and go through it until it finds the right values. Now you need to be careful about that because even though lazy enumerators sound really good, they're also slower if you have short arrays. So you really want to use them when you have really big arrays or enumerators, when you don't really know how far you need to go into the creation of these arrays. There's also one new trick with Tutoro, which is you can set the size of the array, of the lazy sequence before. So you can ask, if the lazy sequence was properly defined, you can ask its size without actually opening it in memory. So if you have, if you create a function, like you have a proc that goes through a lot of different permutations, you could save the result of the permutation inside the lazy sequence. So when people consume the lazy sequence, instead of going through it, they can ask for the size of it, which is just a small detail, but it's kind of cool that that was added to lazy sequences. Any questions about lazy sequences and how they work? No? Okay. So there's a new convention. So this is a feature I saw a lot of people talk about, but it's actually a very small feature. The only reason I mention it is because I think that's going to become a convention in the way people write code. So you might have seen a lot of code where you say dot to hash, and that basically says I want my object and I want to convert it into a hash object or a dictionary. Now, in Ruby 2.0, they added this 2h, which basically converts an object into a hash. But they only added that to a few classes, and especially for struct and open struct and nil. So what that means is if you create a struct, which is basically like a class, and you can have a body, you can define methods in struct and everything else. But once you have your struct, if you say 2h, it gives you a hash of the value that you have in the struct. Now this is not very useful because not a lot of us use structs on a daily basis, but I think what's interesting is that 2h is the new convention in 2.0, and now I basically went into some of my code and I removed the 2 hash I had to use a 2h in this case. Just small feature, but I think we're going to see a lot of people use that, especially since JSON is now everywhere. A lot of people do a 2 hash and then 2 JSON. So that's a cool new feature. Any questions? Probably not.
Is it just an alias to 2 hash?
Is that an alias? No, it's not.
So what's the difference?
Well, there was no 2 hash.
Oh.
2 hash doesn't exist on any of the main classes in Ruby. Usually we define it ourselves, and that kind of became a convention to do. And when you do a JSON, when you do 2 JSON with the JSON gem, automatically we look for a 2 hash. And that's why people started doing it, but it looks like now we're going to a 2h. So, not a big change, but it's just a convention.
Why not 2 hash?
That's a good question. I don't know.
2s, 2a.
2s, 2a, yeah, probably just
Okay, convention.
Just convention, yeah. And it's shorter, you know. All right, this is a feature coming directly from Mr. Tenderlove himself. You can create literal symbols in an array now. A very small feature, but if you see it the first time, you'll be like, what's going on here? So if you do the %i, and then you use whatever delimiters you want, everything gets converted into symbols right away. So you don't get a string to a symbol, that becomes a symbol right away. Small feature, something tells me we're going to see a lot of code from Aaron using that, so I just wanted to warn you. I don't expect you to have any questions. Any questions? No? All right, that was a very simple feature. But thank you, Aaron, for that. So Tracepoint. Tracepoint, oh, I forgot to put the slides. Okay, it's okay. I'll explain to it. I actually wrote a blog post this week about Tracepoint. Tracepoint is a new API that was added to Ruby 2.0 that lets you trace through your code. And the way it works is you can start it and stop it wherever you want, and you can listen for specific events, such as methods being dispatched, classes being open, a line being executed, things like that. So using Tracepoint, I wrote a simple middleware for Rails that was loaded just before Rails would start to process a request. And I would monitor everything that was going on until the request was ready to be sent back, and then I stopped the tracing, and I put all of that into a big hash. I did not use 2h, I should have done that. I put all that in a big hash, and I counted how many classes were being used, how many methods were being used, and how many methods were being dispatched, because the same method can be dispatched many times. And in the case of Rails 4, I found 250 classes, 750 methods, and I forgot how many thousands methods being dispatched just for simple hello world. So it's a great tool because it lets you look into what's going on with your code. So you can profile and see what you're actually doing. In the case of Rails, I found some interesting places. Like, okay, that's interesting. We're using that in development when you basically request an asset, a static asset. I could see all the methods called by Sprocket and everything else. Like you do 10,000 method dispatch. You're like, well, we could probably optimize some of that. Another feature we could build around that is to find dead code in production. All of us have written a lot of code that we might not be using anymore. And using an API like Tracepoint, we could sample some of the requests and see what code is being executed And the code that's not being executed in production could be flagged for deletion because we would say, oh, this code is probably not used, we should get rid of it. So Tracepoint is an interesting way of looking into what's going on when your code is being executed. We're going to talk a little bit about Dtrace. It's basically the same concept. But what's nice with Tracepoint is that it's an API in Ruby you can use inside your code. And you can basically take a small block and look at what's being dispatched. If you don't really know where things are coming, it's a cool way of looking into your code. There was also a garbage collector and some other optimizations. I don't want to go too deep into that, but the main thing you need to remember is that with Ruby 2.0, the garbage collector is now copy on write friendly. So there is a change called bitmap marking change into the garbage collector, which means that when you fork a process, so let's say you have a rescue job running, so you have a worker running, and it would take a new job and it would start a new process. That's called a forking process under Linux. So you have the main Ruby process, you start a new Ruby process, and this Ruby process before 2.0, if you were not using Ruby Enterprise Edition, you would basically copy the entire memory of this process and copy it here. So if you're running a rescue job for a Rails app and your Rails app is like 200 megs, when you fork the process, this other process is also 200 megs, and then it dies, and then the next one is 200 megs. So if you start 5 processes, you have 5 times 200 megs. Now with the new garbage collection, what happens is when you fork the process, the memory is shared between the parent and the child, and only the new memory allocated in the child process is allocated on this specific process. Which means that forking is much faster and cheaper because you don't need to copy all the memory all the time. So that's actually a cool optimization. So if you use Unicorn, Unicorn works the same way. You have one main worker and you start other small workers or other workers to handle the request, and they will basically share the same memory. Well, they will share the parent memory, but all the memory allocated on each of them will be specific. So it's a nice optimization. You should see a better memory footprint for your apps if you switch to 2.0. So what else we have? We have a lot of small, tiny features. I don't know if you ever use caller, but if you're inside the method, if you call caller, you can see the entire stack. So who's been calling this method, and you can actually work it through. This is a bit slow. It's actually quite slow, and you should not really use it in production. But a lot of people do. You now have these caller locations that lets you find where the method was called, and you can ask for the label, for the line number, and some of the other information, and that's a really fast call. So you can say, just show me the parent. You can use caller locations. That's a really fast call. So that's very nice when you do debugging, or if you want to see what's going on with your code. If you use caller, now caller has a new argument called length. So you would say caller start, which means tell me in the backtrace when I want to start getting the caller. So usually you'd say, I think 0, 1, I forgot what's the first index. And then now you can say just give me 5. So instead of creating the entire call stack in memory to show it to you, it would just create 5 of them and give them to you, which is a small optimization. Dtrace support, it's a bit like a Tracepoint. I didn't want to show you examples because first it only works on Solaris and Mac OS X, and I would guess that most of you guys deploy on Linux, so that doesn't work. Dtrace is very nice because in runtime you can inspect what's going on in your code. So you can see what methods are being called, how they're being called, and you need to write this nasty Dtrace script, but you can get a lot of information off of the runtime without affecting the performance that much. There are also the refinements. So refinements is a big topic in the Ruby community. We have a lot of people like to complain about them. I don't really care too much personally. The idea is a very nice idea, which is people monkey patch a lot Ruby, and instead of monkey patching, what we could do is you could define what you want to monkey patch and only apply it in a special context. So the main example would be the way Rails monkey patches time and string and everything else. You could make it happen only in the context of Rails, which is good. The problem with refinements though is that performance can be affected, and other implementations have a hard time doing what CRuby does. So it was flagged as an experimental feature. If things go well, it will become an official feature, otherwise it won't. But because it's experimental, I recommend you don't really play too much with it. I mean, you can play with it, but don't use it in production because it might just go away. A lot of people wrote about it. You can Google it. People seem to be upset about it. Some people just don't seem to care too much about it, like myself. But I like the idea personally. I like the idea of being able to do clean monkey patching. I just hope they will find a way of making it happen in a way that makes everybody happy. Small little feature, we now have binary search for array and range. So what that means is if you give it an array or range, you can say based on this condition, and it will basically it will do binary search. So take half of it and search the other half until it finds the results. If you do a lot of search in arrays, it might be an interesting feature. It's a very small thing. One that might get you is Kernel Inspect is different than Kernel toString. So what that means is if in your class you have a custom class and you define toString, and then you do an inspect on your object, you might expect the inspect to return the toString, but it's not the case in 2.0. I'm not sure why that was changed, but that was changed. So if all of a sudden you do an inspect and you don't see what you're expecting, it might be because of that. So hopefully you will remember this talk and you'll be like, oh yeah, I know. String B, that's a new feature for string. So encoding, the encoding in 1.9 is really what threw a lot of people off because now you have like different encoding that were built into the strings. And if you have something like déjà vu, that's a string that's in UTF-8, and you have an encoding that's already set. But if you need to send it through the wire using a binary protocol, that's not going to work. So you need to convert it. And the .b basically creates a copy and sets and switches it to a binary and puts the right encoding and send it to you. So it's it creates a copy and you have it available. So it's useful in some specific cases. A weird one that I found too is you can set thread variables on a thread using this new this new API, which is a bit nasty, but I guess they didn't want to break things. The idea is when you have two different threads, you might want to set different variables on these threads so they don't conflict with each other. And the way a lot of people do right now is you say thread current and then you access a hash, and this hash is where you put your stuff. Well, now you also have this option of setting the variables instead of just using the hash inside the thread. It's a bit weird, but I don't know if people are going to use it or not. The full list is available on GitHub. So if you go to the Ruby repo, make sure you switch to the branch for Ruby 2.0 because they're already doing the new features for 2.1. So switch to 2.1, you can see the list of all the changes. But as you can see, this is basically all the changes for 2.0. So there are not a lot of changes. It would all be. I was almost thinking about showing you all the cool features in 1.9 because that's maybe what most of you are going to end up using because now that everybody is switching to 1.9 and 2.0, finally everybody's going to be able to start using features like require relative and all the other features you get in 1.9. So I think that's it for Ruby 2.0. Any questions? Yes.
The Tracepoint API you're referring to,
yes.
Does that count those instances by analyzing the virtual machine codes off the runtime, or does that do it by callbacks like inherited?
It does. I'm not sure what you mean, but
is it watching instructions off the runtime in order to find out how many method calls it's doing,
yes.
Or is it doing something like whenever you redefine class inherited to find out to get a callback every time your class is inherited by another
so
class?
I'm not sure about the implementation details. It's a new implementation of set function track or whatever it was called before, but you do get a callback on it. So you can say no, you don't get a callback. I'm not sure. I don't say anything wrong, but I know it's faster than they currently had in 1.9, and you can have blocks. And whatever you redefine will be evaluated in that, so I'm not quite sure. What I did not mention is for Prepen, you can also have callbacks. So, you know, when you extend or when you include, you can say included or extended. You can do also prepended. But for trace points, I'm not sure about the details of the implementation.
Okay. Thanks.
I'm actually benchmarking at work to see the overhead, to see if we can use it in production or not, to just sample some of the requests to see
It sounds like if it's not adding that much overhead, I would almost bet that it has to be just doing virtual machine, reading the instructions off, because each callback would add another method call.
Right. That's my guess, and I know it's optimized for performance
Right.
compared to what they had before, so that's probably what it is, but I don't want to, I mean, I didn't
Right,
get it.
yeah, you just almost figure it from there. I get that. Thanks.
Any other questions? All right, thank you very much.